In the last presentation, we described flight maintenance data management structure. Now let's move one step forward and add to the structure operational reliability. And today we are going to discuss about basic reliability characteristics. And we are going to start from flight. Let's say in our fleet we have only one aircraft. For learning and training purposes, let's keep it simple. And aircraft manufacturer serial number is 1001. Reporting time period is December 2023. In December 2023, our MSN 1001 did 300 flight hours and 100 flight cycles. This information is general given data. Now let's move to the failure. In failure, we are going to calculate failure rate on LRU level, line replaceable unit level. And for this reason, I'm using 8824 electrical power AC generator. Let's say on our MSN 1001 installed 2 AC generators. Quantity per aircraft equals 2. And in December 2023, 1 AC generator failed. We have to calculate mean time between failure. In numerator, we have LRU flight hours. And to calculate LRU flight hours, I'm multiplying aircraft flight hours, December 2023, by LRU QPA. In denominator, we have number of failures. As a result, aircraft flight hours, December 2023 equals 300 flight hours, LRU QPA equals 2, and divided number of failure, 1, gives us 600 flight hours. Mean time between failure for AC generator from 8824 in December 2023 equals 600 flight hours. Now let's move to the incident. In incident section, we are going to calculate incident rate on system level. And for this example, I am using ATA21, which is air conditioning. Let's say in December 2023, it was reported 1 ground tone back due to air conditioning back. Rejected takeoff, air tone back, diversions, aborted approach, in-flight shutdowns, etc. etc. means your business and operational models, requirements, aviation authorities requirements, etc. equals 0. So for system or 8821, we have only one. December 2023, we have only one incident, ground tone back. We need to calculate incident rate per 100 flight cycles per system or per ATA. Now 2 words about standardization number. I'm using here very general, very simplified, very basic numbers, but in real life we can see sometimes airline uses 100 flight hours, 1000 flight cycles, 1000 flight hours, etc. But here, in this example, as I mentioned, we are using for this incident rate 100 flight cycles. In numerator, we have sum of ground turnback, rejected takeoff, air turnback, diversions, reported approach, in-flight shutdowns, etc. As I already mentioned, depends on your business operation model requirements. In denominator, we have aircraft flight cycles per RTP, and multiply it 100 flight cycles. As a result, numerator we have 1 plus 0, 0, 0, 0, 0, divide 100, multiply 100. Gives us 1 incident per 100 flight cycles for 8821 in December 2023. I think it's simple, right? Now let's move the report. In the report section, we are going to calculate pilot reports and maintenance reports on system level. And for this reason, I'm using 8823, which is communication. Let's say in December 2023, PIREP number for pilot reported 4 snags, and maintenance reported only 1. Now, before we move forward, I would like to mention that sometimes airline includes MAREP in PIREP and displays this as a PIREP. Sometimes airline splits PIREPs and MAREPs, and they have 2 sections, one for PIREP, one for MAREP. In our case, I'm going to combine it, and we are going to calculate PIREP-MAREP rate per 1000 flight hours per ATA. In numerator, we have PIREP-MAREP numbers per RTP. In denominator, we have aircraft flight hours per RTP. And all this we have to multiply on 1000 flight hours. As a result, PIREP-MAREP 4 plus 1, 4 plus 1, divide 300, 300 aircraft flight hours, or fleet flight hours in our case. Gives us 16.7 PIREP-MAREPs per 1000 flight hours for 8823 in December 2023. Now let's move to the action. In action, we are going to calculate part removal rate on LRU level. And for this reason, I am using brakes. Let's say on our MSN 1001 installed 8 brakes, QPA equals 8. And December 2023, 2 brakes were removed. You have to calculate the removal rate per 1000 flight cycles per LRU per RTP. In numerator, we have removed LRU per RTP, number of removed LRU. Divide, in denominator we have LRU QPA multiply aircraft flight cycles per RTP. And all these multiply 1000 flight cycles. As a result, in numerator we have 2, because we remove 2 brakes. Denominator we have 8 by 100. 8 is QPA, 100 is flight cycles. And all these multiply 1000 flight cycles. Standardization number. It gives us 2.5 removals per 1000 flight cycles for brakes in December 2023. Now let's move to the impact on operation. For impact on operation, I'm using here delays and cancellations, and we are going to calculate interruption rate or dispatch interruption rate on aircraft level. For this reason, I'm using delays as I mentioned and cancellation. Let's say in December 2023, it was reported 7 delays and 3 cancellations. We have to calculate dispatch interruption rate per 100 scheduled departures. In numerator, we have sum of delays and cancellations, and denominator, we have revenue flight cycles plus revenue cancellations, and all these we multiply 100 departures. As a result, in numerator, delays plus cancellations, 7 plus 3, and denominator, revenue flight cycles, 100 plus cancellations, which is 3, 100 plus 3, and multiply all this on 100 scheduled departures. And it gives us 9.7 dispatch interruptions per 100 scheduled departures for December 2023. Let's move to the another characteristics. It's very popular, so that's the reason why I included here. Dispatch reliability. I'm using same delays and cancellations on aircraft level. We can calculate dispatch reliability on system level, but for this example, I'm calculating on aircraft level. Anyway, dispatch reliability, we need to calculate dispatch reliability per 100% or per percentage. What we have here, 1 minus in numerator, sum of delay and cancellations, delay plus cancellations, divide revenue flight cycles plus revenue cancellations. Multiply this on 100%. As a result, we have 1 minus 7 plus 3 in numerator, divide 100 plus 3, 100 plus 3. Multiply 100, we have dispatch reliability for aircraft level equals, in December 2023, equals 90.3%. Now, if we move back, dispatch interruption rate equals 9.7. If we subtract 9.7 from 100, we will have 90.3. I'd like to mention that approximately, probably 60-70% operational reliability characteristics are derivatives from what we discussed today. I gave you very simple, very basic, very general aircraft operational reliability characteristics. Homework. We need to calculate cancellation rate. And we find out the answer during our classes. As always, I personally invite you to join our reliability program trainings. We have 2 sessions per year. You can check our ramaerospace.com. Thank you very much and see you next time. Bye.